Hello and welcome back to a new video in my advanced networking series. Today we're going to talk about the OSI model, or how does Ethernet communication works from bits to the service. So the OSI model is built from a stack. Every component in that model or in that stack works and can also be implemented differently. And several networking equipment is actually targeted to take a look at certain parts of the data associated with one layer or more of that stack and can then decide on the layer it is currently inspecting on or modifying on, how the data needs to be redirected, or how the data might need to be processed further, or if data might be dropped because it's not allowed to travel that way. So this is all kind of like evolving around that OSI model. OSI stands for Open System Interconnection. And basically the OSI model itself is not only used for networking, it's also used for many other things. But in this case, we're gonna just take a look at this for networking. Alright, there you have it. This is the OSI model. We have 7 layers, starting here at the bottom with the layer 1, going up to the top to layer 7. And each of these layers has a different job when it comes to communicating over network. Just as a basic understanding, the sender of a network, not talking about packets yet, but basically if somebody wants to send some information over a network, it is starting from the highest layer in that OSI model, and it always passes its data onto the next layer, and the following layer then passes the data on again and again and again. At some point we are at the lowest layer possible, and the lowest layer possible is the layer that can physically transfer the data to the next networking device, and at some point we end up at the receiver that can then operate in the different ways, so starting at the bottom and constructing itself up until the data is ready and presented to the application that we have just implemented. So the lowest layer in that stack is the physical layer. This is basically the physical connection, so the twisted pair Ethernet cable, a fiber optic cable, a wireless networking, so basically the transmission of bits. Then it's gonna be packed into the Dato-Link layer that is kind of like connecting the bits together. Then it's gonna be passed in the networking layer that handles like addressing. Then it's going to be passed to the transport layer that is kind of like how the communication is established, so an end-to-end connection, as you may already have heard, TCP or UDP. Then it is going to the session layer, which is basically a API that is our application talking with, so WinSocket, socket programming, so basically the API that the programmer is writing for on Windows WinSocket, on Linux different systems, so basically some continuous data to a session. And the data is then interpreted by a presentation layer, and finally an application layer that handle encryption and the protocol itself, so an HTTP website, for example. Let's talk about each of these layers. Let's start by the physical layer. Basically, the physical layer is a bare metal transmission technology. So how does the bit stream flows? This could be, for example, a differential pair, a wireless network, or fiber optics. If you might be interested in that, fiber optics is the connector in this image here. And down here we have some twisted pair Ethernet. But we're going to talk about fiber optics in the future as well in this video series. There are several devices that only operate on the layer 1. For example, a cable basically is a layer 1 device. It's just passing on the data. There are also devices called a hub, so where one cable or one like endpoint is sending bits in, and the hub is just putting it on other ports out again, so just replicating the signals. Same goes for repeaters, so you plug in one cable at the one side and another side at the second side, and it's kind of like amplifying the signal so it retains strength. Or for example, networking bridges, if you have a media change, a media converter where you plug in an Ethernet cable at the one side and a fiber optic cable at the second side, and it's just kind of like bridging the bits that are transmitted, then basically we are only operating on that lowest layer, on the layer 1. Next layer in the stack is the Dato-Link layer. This layer is packing the raw bits into bytes and these bytes into frames. And by doing that, it produces network packages. It also does error detection, so there is a checksum that is transmitted with each network package that can be used later on to verify if a packet needs to be dropped. So if the checksum is not good, it's basically not valid, the packet. Some examples for some data link layer protocols are Ethernet. This is like the most common thing that we are also going to use. This is, for example, the Ethernet frame, so we can have the source address and the destination address, but not from the IP address standpoint. It's from the MAC address standpoint. MAC address is basically the physical unique address of your networking adapter. And this basically handles the higher level communication. The MAC address is fixed. Devices are responsible for building these addressing tables so that they can translate an IP address to a MAC address and so send the proper packet out. So this is all done here. And it's basically just a little wrapper around the data. There are also different protocols that might be used on the data link layer. One example would be PPP, point-to-point interface. This is a special interface that is used for dialing in over telephone lines. For example, VDSL in Germany is using the PPP protocol. And if you would want to use PPP on your networking equipment, you would have a bridge, a layer 1 device, that is basically taking the PPP signal and presenting it as a PPPoE, a point-to-point over Ethernet signal, which then can be used by a special device that knows how to dial into your ISP. So basically there's a protocol which you then can use from PPPoE, and then you can say, hey, for example, Telekom in Germany, hey Telekom, this is my username, this is my password, give me internet, and the Telekom says, yeah, here you have your internet access. Just a bit going over that. Some examples for layer 2 devices are layer 2 switches, so switches that can actually operate on these frames, so it can detect the source MAC address and the destination MAC address, and can, by these two addresses, decide where the packet should go. The source is not that important, but most of the time it's been inspected sometimes as well, especially if a layer 2 switch is using VLANs. We're gonna get to VLANs. It's basically an extension to that Ethernet frame, a VLAN, but we're gonna get to this in the future. But if you have that VLAN thing, then it might be actually determined by the source MAC address. There are also other layer 2 devices, for example, intelligent bridges. So a networking bridge could also be intelligent, and it knows basically which addresses are on the one side and which addresses are on the other side, and then it only forwards the packages to the other side if the destination MAC address is actually on the side where it should be transmitted to. Next layer in the stack is the network layer. The network layer is used to route packages through the network. So last video, routing, this is basically where routing happens, layer 3. So basically what you can do is with the layer 3, the networking layer, is you can address packets. This is done by IPv4 and IPv6, or also by other protocols like ICMP. So basically, I mean, it's a bit more complicated, this header, and we're not going to talk about this too much, but basically here you can see this is the IPv4 header format where we have the source IP address and the destination IP address, and layer 3 devices can operate on them. For example, layer 3 switches, which are basically just a router and a switch combined, can basically analyze this header and then decides if the package needs to be routed. This is the thing that we also had with the default gateway. So this is all something that's happening on the layer 3 switches and routers. Now going to the next layer, the transport layer. The transport layer is responsible for end-to-end communication and error detection and correction. Basically, what end-to-end communication means is we already got the IP addresses, so we can directly address a device, so we can directly address one computer, but we cannot determine the endpoint. And with TCP and UDP, we can specify a so-called port, and this port is the endpoint we want to connect to. For example, a server in a network or a device in a network can actually serve several endpoints. So, for example, a TCP endpoint with the number 443, for example. it can serve that endpoint, and basically what it tells the operating system, hey, I want to serve this endpoint application, and then the operating system knows that every incoming request to 443 in this example is being routed to that application, and with these extensions, we have an end-to-end communication, because any client in the network can open up a connection and say, I want to connect to this IP address, to that port with that service, and we can directly route this to an application. So we have an end-to-end communication between two applications running on two systems, for example. It also provides additional error detection and correction. This is actually redundant. It's not going to use the error detection from the basic networking package, because the networking package error detection is most of the time not forwarded by a switch. So a switch just checks if the package is valid, and then it generates a new CRC, a new error detection checksum, and sends it out again. So if the data is corrupted on the switch, the CRC will still be valid, and so we have an additional software error detection in there, or might also be hardware error detection in there, and also the full correction mechanism. So a TCP package is working with error correction, and if a bad package is coming into TCP, a TCP served endpoint, then basically the transport layer just asserts that basically if the packet is invalid, it asks the sender to resend the package, basically. So this is something that's going on that transport layer. The next layer is the so-called session layer. The session layer is responsible for syncing the sender and the receiver. So basically, until now we just had some packages. If the data was bigger than the package, we had an issue, because we need to send two packages, and if they might be routed differently, and one package and the second package is arriving before the first package, why should this be? It could be that one package is delayed and the other package is picked up by a different router, and maybe on the one side the switches were all like running a bit high on their CPU power, and they weren't able to fulfill the request very fast. There's a queue in some networking equipment. Basically the queue fills up, and the switch is just, or the networking equipment is just behind of its work, and then it could be that one packet is arriving, that the second packet is arriving earlier than the first packet being sent. So basically the session layer is responsible for syncing all the data back together, and also splitting large data into smaller packages so that they can fit this layer 4 package. And it's also responsible for deconstructing the input data to the separate packages, sending them, and also on the other side getting the packages, bringing them back into order, and reconstructing the data. An example for the session layer would be sockets or WinSockets, which is basically the API you are talking to. So basically Windows internally, after getting like proper TCP packages, is kind of like building them up together so that the session itself, the sended data in a session, is actually intact. Next layer is the presentation layer. This is the data, how it is presented to the application from the underlying API. And this is kind of like a special layer, because it could also be that the data is presented as plain text. For example, if you have SSH without encryption, I mean, it's probably not going to be there, because SSH files always requires encryption, but whatever. Basically, if you have some unencrypted data and unencoded data, then it is actually presented in the same manner than it's been interpreted by a higher layer. But most of the time in current days, we have some encryption going on there, or at least some encoding. So basically, the data gets encoded or encrypted, and this is all done by the presentation layer. So we are presented with some junk that nobody can read because it's encrypted, and the presentation layer is responsible for decrypting the messages, encrypting them. An example here would be SSL. Next layer in the stack is the application layer. This is actually the end application protocol, so a well-defined data and communication endpoint. So after all that hassle that has gone down in the other layers, we are now presented with some valid and continuous data that we can operate on. For example, HTTP. An HTTP request that gone to our server, or an HTTP response that represents a web page. So this is like the higher levels layer where the data is actually valid and we can do something with it. Or for example, SSH command, mail protocols, IMAP, POP3, or DHCP. So this is the end of the stack. What's coming up next is an explanation, a few of these type of packets and protocols that we're gonna massively use. We're gonna use ICMP. We already use ICMP by pinging. trying to reach a connection, and that you can actually understand what this is. We're going to have a separate video dedicated to ICMP and all of its glory. We're also going to learn a few more comments beside of ICMP, so that you can actually see what you can do with all that stuff. And we're also gonna talk about after that about TCP and UDP, which are the most common protocols used on the internet. TCP/IP for nearly everything, UDP for some very fast and reliable, or not reliable but mainly fast protocols. TCP has automatic error detection and UDP not, so UDP is faster but it's not as reliable. I hope you enjoyed. In the next video we're gonna talk about ICMP. Thank you for watching, have a nice day, make sure to like and subscribe, and bye!